All right, so we are doing lesson 2-7, and it is taking a lot of what we've already learned about slope, which there's a lot of different terms for slope. Sometimes you'll hear it called the rate of change. You'll hear it called slope. We talked about the constant of proportionality, which is just, the constant up, over, up, over, up, over. Sometimes it's called change in Y over change in X or rate of change. There's a lot of different terms, but it all means the same thing, which is how a line between one point to another, what is the rate of increase over up, over, up, over, up, over, up, over. Okay, so that is what we're going to kind of expand on today. I think this little part here is a little bit of a review, but we're still going to review it. When you are talking about the equation y equals mx, this actually is kind of partial, right? That's really not the whole equation. Really, technically, what you guys have learned, I believe last year, was y equals mx plus b. Okay, so technically, there should be, and you don't have to write this, but technically there should be a plus b here. When it's not there, it's because the value of b is 0, and so we just don't write it. So that's why it's not here, because everything that we're going to be dealing with today in 2-7, there's actually, your b is a 0. And so technically when your b is a 0, you just don't write it, okay? And I try to always actually work your homework as a student before I assign it to you, because I want to know what you're looking at. I want to know what kind of problems you're going to have. And then if there's some wonky problem I like to throw out, I always work your homework. And I'll just tell you, on problem number 1, I got the slope, or the m, or the constant rate of change. I've got that, and I entered it y equals, let's say it was 2. I don't remember what it was, but y equals 2x, and I put plus 0 in the computer, and it said, fantastic work, great job. It gave me thumbs up that it was right. Then I go to problem number 2. It was the exact same kind of question. And let's say the right answer was 4. And so I put y equals 4x plus 0, and it counted it wrong. And when I went to see why, it didn't want the plus 0. So go figure, exact same homework assignment, problem number 1, problem number 2. And on problem number 2, they counted it wrong and said almost. So my advice to you, just leave the plus 0 off. You just have to know it's there, and we'll talk about why here in a little bit. You have to know it's there, but I would not tack it on to the end of your answer for Savvis or Khan Academy, okay? It's just, I don't know, it's technicality. Apparently they didn't want it in one of the problems, but they did in the other, so I don't know. And we've talked about what that m is, right? So the m is the slope. That's what the m is. The m is the slope. Again, also known as the rate of change, constant of proportionality, all of that. That's what the slope is, okay? It's how it moves. And then the b is the y-intercept. That's what the b is. And that's just a fancy term for where your line crosses the y-axis. That's what the y-intercept is, okay? Think of intersection. It's the intersection of your line and the y-axis. That's what the b is. And in everything we're going to be dealing with today, your b, or your intersection point, is going to be at 0. So it's going to basically come from the origin, all right? So earlier in, I think it was 2-6, I think, when you had story problems and you had to compare things, compare all the constant of proportionalities. If you were given to it, like if you were given information like this and ask what is the constant of proportionality or the slope, what would you say? What would it be from this? Yeah, 28. It's right here. It's in the m spot. So it's super easy to find the slope when you're given an equation. You just pull it right out of its spot. It's always in this spot right here next to the x, okay? So like on the flip-flop, if I tell you the slope is 10 and say write an equation, it's just as easy. If I tell you the slope is 10 and then ask you to write an equation, you would just write y equals 10x. So really, this is not too difficult of a lesson. It really kind of makes sense with what we've been doing so far with 2-5 and 2-6. Okay, so the constant or the slope or the rate of change, whatever you want to call it, it's always right here in the spot between the equal sign and the x. Okay, y equals mx plus b. The m is always after the equal sign. Okay, all right. So with that in mind, let's jump to page 134. And we're going to do a little bit of review because this is what we did in 2-5. We were given 3 bits of information and we needed to see, was this a constant rate of change or was there a constant of proportionality here? Well, if we're given 3 different bits of information, how do we compare them to see if they are all equal or if they're all proportional? Anybody remember what we did? We were given 6 feet of fence equals $30. 15 feet of fence is $75 and 24 feet of fence is $120. How do we know if these are all the same, if they're charging the same amount at each level? How do we know? Nobody know? Yes.
The bigger number divided by the smaller number, they all equal.
Yes, except it's not always going to be bigger divided by smaller, but you're on the right track as far as you set up a division problem and then you reduce it and see if they all equal the same thing. So I just want you to be careful. It's not always going to be bigger over smaller. It's always going to be, y over x, right? And in this case, you don't see it, but in this case, it's distance over time, it's money over units. Okay. So in this case, it's 30 over 6, which reduces to what? Anybody? 5. Okay. Now let's check the other ones. Let's do 75 over 15, and let's do 120 over 24. And what we really want, yes, it's 5, and that is the right answer, and that's how you would always write it. But think about what it really means. This really means 5 over 1. So what this means is for every 1 foot of fencing, they charge $5, right? That's what it means. So the unit price of a 1 foot of fence is $5. So let's check the other 2 to see if it's constant. Okay, because some stores, they give you a discount if you buy more. So we need to check to see if this is proportional, if it's a constant proportion. So let's go. Jacob, what's 75 divided by 15? And then I'll jump to this side and I'll say, Olivia, what is 120 divided by 24? Miss Borden. I sure will. Thanks. Your lunch is in the office. All right, so who was doing my 75 over 15? What does it equal? 5. Beautiful. Okay. Olivia, 120 divided by 24? 5. All right, so what we have found is that there is a constant proportion, right? Or there is a consistency here that for every 1 foot of fencing, they charge $5. So if I asked you to write an equation for this, you could do it. You could say y equals 5x, and that's it. That's as hard as it gets. You find the slope or the rate of change or the constant of proportionality or however it's worded, and then you stick it in the M spot. Okay. All right. So they have kind of expanded on this a little bit. We're just going to talk through a little bit of this, but not spend a lot of time on this. They've graphed those points. Okay. So this is that 1575 point. They graphed it. And then this is the 24,120 point. And then they've even graphed some more points. And the reason they can do that is because we know the rate of change now. And so you can keep moving up this line and you can keep increasing 5 over 1, 5 over 1, 5 over 1. And you can keep moving up the line and you could actually add as many points as you want. Okay. And what if we take a bigger chunk? What if because we know the difference is, we know the rate of change is 5 over 1. And so we go here, they went up 45, right? So that's 45 over 9. And we know that reduces to 5. Here, the rate of change between the blue point and the green point was 130 over 26. And if you punch that in your calculator, you're going to get, no surprise, 5. And we could even do a big jump. We could even do from the red point to the green point. We could even do a big one. We could go from, what was that? 75? Isn't that what that would be? Isn't every box worth 25? So if we did 75 minus 250, that's what? Or 250 minus 75, sorry. That's 175. So my rise is 175, right? That's that's the difference from here to here. That's a difference of 175. So I go up 175 and then I run from 15 over to 50, which is a 35. Anybody want to guess what you get if you punch that in your calculator and reduce it? Shocker, you ready? You get 5. Okay, so no matter what 2 points you pick, you set them up as a you set it up as a fraction, the change in y or the rise over the run, and you reduce it. And every time you're going to get it, it's going to always reduce to 5 on this particular graph because that is our constant rate of change. Okay, and this is just saying the exact same thing. So I'm not even going to take the time on this. Okay, rise over run. All right, and we already did it, but they do it here. They write the equation. And with that equation, I could ask you, how much would 100 feet of fence? Or how much would 250 feet of fence? Or how much would 800 feet of fence cost? And you could figure it out by taking the feet times 5, and that would give you the total of the whole job. Okay? All right. Well, now it says try it. Well, there are 2 different ways to try it. You can use whichever method you want. They give you boxes here to fill in using the equation like our jump start. And they give you a graph. I'm a visual person, so I like the graph better. So I'm going to find the slope on the graph, but you can find it by plugging it into that equation as well. Okay. All right. So how do I find the slope on a graph? Well, I need to find 2 good points. A good point is right on the intersection of 2 grid points, right? And where your line hits. Well, I like it because it's easy. Is this a good point? Miss Gordon. Okay, I'll send him down. Thanks. Dayton, they need you down in the office, so you'll need to finish listening to the video to get the rest of the notes, okay? So start at about the 10-minute mark, and that should get you. Okay, so I picked a good point, and I picked this point right here at 0, 0. Okay, now I need to pick another good point. So I'm going to go up my line until I find another good intersection, and there's a nice good intersection right there. Okay. So now I need to figure out what is my rise over my run, right? And I notice I always make this box. It helps me to know what I'm doing here. So my rise is how much do I change here? And it's not one box. I don't care that it's one box. I care what that box represents. And in this case, it's what? I'm doing m equals, what's my rise? Look at everybody not wanting to look at me. Dalton, what's my rise? No, I do a 1 whole box. I go from here to here. So I go from 0 up to 20. So that's a change of what? 20. Good. 20. And then my run is from 0 to 1 because I want to know what's my side-to-side movement. And Aiden, what's my side-to-side movement? 1. And then usually we want to reduce this and write it cleaner as 20. Okay. I don't know if Savas would count it wrong if you put 20 over 1. I'm not sure, but since it can be reduced and written cleaner, let's write it. And then with that information, I can very easily write an equation. Y equals my constant and then X. Y equals 20X. That's the equation for that line. And like we said before, right? It's there, but it's not there. And you don't even have to write this. Technically, it's plus 0 because that's my B or my beginning point, and my line, right, crosses the y-axis. Here's my y-axis right here. My line crosses my y-axis, or actually it originates from the point 0, 0. So that's why that plus B is there. But like I said, just to keep it safe, let's not put plus 0 because Savas might count you wrong. Okay. Are we good? Not too bad? All right. This one, again, and like I said, if you wanted to fill in all those boxes, you could. You're still going to get 20 over 1. You're still going to get right here, and you would put a 20 right there. Okay? I don't know. We'll just see how fast we can get through it. But we are going to, I want you to do the best you can on your homework, but if you come in with a few questions at the beginning of the hour, obviously if you don't have any of it done, that's a problem and you would get an incomplete. But if you come in with a few questions, we'll take the first 15 or 20 minutes of class to answer questions. Okay. All right. Example number 2 is very much the same. Okay. Now the graph looks a little weird because it's upside down, but it's still the same. It still originates right here from 0, 0. It's just, we're not used to seeing the graph upside down, but you still would read it the same. Okay. And I'm going to find 2 good points. Can I use 0, 0 as a good point? I think it's the easiest point. It's a great point. So I'm definitely going to use it as one of my points. Now I'm going to go up my line and I want to show you this. This technically is a good point. However, I don't really want to fill in the gaps with a 1/2 and try to figure out what this is. So I'm going to skip that good point and I'm going to go up my line a little bit further to this good point. Okay. And the reason is because that good point is sitting right over a 1 and a negative 250. And I don't have to worry about filling in the gaps of my graph. So you can skip one good point and go to the next good point. If I wanted to, I don't, but if I wanted to, I could skip all the way out here to this good point. It's fine. It's just going to be a little bit more counting, but it would still work. Okay. All right. So I'm going to use the blue point that I used there as my good point. And now I'm going to find my slope. My slope is my rise. And in this case, it's a fall, right? So I'm going to, whoops. I'm going to fall from my red point down to where I'm level with my blue point. And I'm going to see how much I fell. How much did I fall from 0 to negative 250? Well, since I started at 0, that's kind of easy. I fell negative 250, right? That's why using that 0 point is kind of nice. And now I need to look at my run. So I turn the corner. Notice I always kind of create this little half box. Your rise or fall over run always should create a little half box. How much do I run? I run from 0 to 1. Again, I don't care that I ran 2 boxes. That does not matter. What I want to know is what do those 2 boxes represent in this graph? And in this graph, 2 boxes represents 1. Okay, so that's kind of hard to see, isn't it? Let's just going to move that over. There we go. So I fell negative 250 and I ran 1. And again, I would clean this up and just write it as negative 250. Okay, it's just a little bit cleaner version. Now I do want to show you, okay, that what if, just really quickly, I don't want to spend too much time on this, but what if I had gone up this way and I did rise, okay, and I rose, now that's going up. So that is a plus 250, right? But when I run backwards. And because I run backwards, it's a negative 1. And when I write that, I would write that as 250 over negative 1. And it would still reduce to negative 250. Okay, so notice you get the same answer either way. Whether you do fall and run to the right or rise and run backwards, why did I get a negative slope? Looking at the graph, why does it make sense that I got a negative slope? Yes, my line is going downhill, so I should get a negative slope. If I don't, that should be a real quick red flag that you forgot a negative sign. Okay, with that, can I write an equation? Super easy, fast. Yep, y equals negative 250x. Okay, the equations are super easy to write once you find your own slope. And does it make sense that there's no plus b? Yes, because it's technically 0 because my line originated right here out of that 0, 0 point. Okay. All right. Now we're going to kind of do the opposite. Now we're going to go from an equation and we are going to create a graph. Before we had a graph and we created our equation by finding our own m. Now we're going to, they give us the m, right? They give it to us right here. Here's our m, 1/2. And we are going to graph the line. So, and I'm going to show you, I don't actually like the way the book does this, so I'm going to show you and kind of fix it. Now, this is where the knowledge of that B comes in because it is not there. But do you have to know where your line begins before you can draw it? You do. So this is where the knowledge that it's y equals mx plus b. And if there is no b, this is where the knowledge that it is a 0 because you do need to know where to begin. Our b is 0. That's going to be our beginning point. Then we also have to know our slope because we have to know how to move from the beginning point up to the second point. And our slope here was given to us. It was 1/2. And it's positive, so we know that our line should be going uphill when we're done. And what this 1/2 means is it's 1 up and 2 to the right, right? Up 1 over 1, 2. That's what rise over run means. Now, I will show you what I mean by I don't really like the way the book does this. So our beginning point is right here at the origin. So that is your beginning point. That's your first point you have to plot. Now they do the run first and then they rise. I don't really like that because we say rise over run so much that I like to actually graph it that way too. It just helps keep you always doing it the same way. So I begin at my beginning point. So I put my pencil on my red point that I just plotted, and I know that I'm going to rise 1, and then I'm going to run 2. And that lands me my second point. So you go from your beginning point, you follow your slopes instructions, rise 1, run 2, and where your pencil is at that point, that's where you land your next point. And if I wanted to, and you don't have to ever do this, but if you wanted to, I could rise another 1, I could run another 2, and it's going to land me on another point right on my line. And once you have 2 points, then you would just come in and you would graph the line. Okay? Good with that? Begin with your B. If it's not there, it's 0. And then use your M to go from your B, rise, run, however much you need to rise, run, or fall, run. If it's a negative, you have to fall. All right, so now we're going to do try it. And this is the last 2 examples we're doing. And then I will set you loose to have a few minutes at least to get started on your homework before class gets over. So we got 1 of each. We're going to write our own equation from a graph. Then we're going to have an equation and we're going to write our own graph, right? So we're going to do 1 of each. So write your own equation. What's the one thing we need to write an equation? Yes. No, we've got a line. We've got a lot. I mean, yes, we are going to have to pick 2 good points. I'm sorry, you are right. But why am I picking the 2 good points? What is it I'm trying to find? The slope. I need an M, right? And to do that, I need 2 good points. Now, I am going to kind of make my life easy. And because it's going right through the origin, I'm going to make that my first good point. Now I'm going to go up and find another good point. And this is, I've kind of already talked about this, but I'll show you. I could pick that as a good point. And if I do, I have to use a little bit of common sense, and I have to come in here and I have to fill in that that would be a 5 and that would be a 2. Now, what if I don't want to do that? What if I don't want to try to fill in the gaps? Can I go further up the line and find another good point that's sitting right on something that's already numbered? You can. It doesn't hurt a thing. So I'm actually going to pick this as my other good point. And the reason is because it's right at a couple of really nicely already labeled lines. And that way I don't have to think too hard, right? Work smarter, not harder. So to find my slope, it's rise. Okay, how far do I rise? And again, I don't care that it's 2 blocks. I want to know what the numeric value of my rise is. So what's my rise here? Who haven't I talked to? Jace, what's my rise? 4. So that goes in the top of my fraction. Now I need my run. So I'm going to turn the corner and I'm going to run. And again, I don't care that it's 2 boxes. I care what's the value of that run. And Briley, what's my run? It's 2 boxes, but how much number-wise, how are those boxes numbered? It's from 0 to there. No. Let me help her out. Corbin, what is it? No, not 1. 10. It's 2 boxes. You were correct. Okay. It is 2 boxes, but on this particular graph, and every graph's going to be different, but on this particular graph, 2 boxes is a move of 10 because of the way the lines are numbered. So our bottom number is going to be 10. Now, should we reduce? Yes, yes, always and forever reduce. So how does this reduce? Yep, so it would give what? 2/5. Now, I want to show you something. Do you know why I had to reduce? Because I skipped my first good point. Okay? Because I skipped my first good point, that tells me I'm going to have to reduce. And that's no big deal. It's just one extra quick step. Because had I taken the time to fill in some gaps here, if 2 blocks is 10, then I know 1 block is 5, right? And if 2 blocks on the y-axis is 4, I know 1 block is 2. And so had I, Jacob, had I landed on that first point that I said I skipped because I didn't like it, what would I have called my rise over my run? My rise would have been what? Just the orange, Jacob. No, my rise. 2. And what would my run have been? 5. Notice I don't have to reduce if I pick my first good point, but if I skip my first good point and I go up to another one because it's a little easier, then I'm going to have to reduce. Okay, hopefully that makes sense. Now, with that information, the instructions said write an equation for the line. Well, I found my m, so now I can write my equation pretty easily. It's y equals my m and then x. And it's there, but it's not there. The b is a 0, so I'm not going to write it, but I just need to know it's there, and that makes sense because my line went right through the origin. Okay. All right, so I wrote an equation based on a line. All you have to do is find your m. Now we're going to do it the opposite. Now we are going to be given an equation, and we're going to graph the line. You need 2 things to graph. You need a beginning point, which is your b, and you need an m because you need to know how to move. Okay, you need a beginning point, which is your b, and your m or your slope tells you how to move. So in y equals mx plus b, if it's not there, what is my b? Yep, because you got to remember it's not there, but it's there. So my b is a 0. And what's my m? -3. Now, I need a rise over a run. So I really need a fraction here. Can I make this a fraction without doing any harm? Put it over what? Now it's a fraction. Okay. So let's graph our beginning point, or our b, which is 0. So that means right on the origin is our point. Now, unfortunately here, we're going to have to do a little filling in some gaps because my slope is down 3 and my graph is numbered in 4s. So I'm going to have to come in here and use a little bit of common sense. If 2 blocks is worth -4, 1 block would be -2, which means even less than that, right in the middle, would be -3. Okay, there's 1. And then on the x-axis, I could put a 2 here, and I would need to put a 1 here, right? I need to have the little half movements here. So now, from my beginning point, right, I put my pencil on my red point right in the middle. That's my beginning point. And from there, now notice it's -3, which means I have to fall. Okay, you have to be careful. It means you have to fall because it's negative. So I fall from my red point, I fall -3, and then I run 1. And that puts me right there. And we've talked about this, and I don't want to confuse you, but I am going to throw this out at you real quick. Is this the same? Does it matter if the negative sign is in the top or the bottom? What this means is you would rise 3, but you would go backwards 1. Well, let's rise 3 from our red point. From our red point, let's rise 3 and go backwards 1. Does it still land us on the same line? If I draw a line through that red and blue point, is it also going to take me through the green point? It will. Okay, so my line should look like that. Gut check. I have a negative slope. Should my line be running downhill? Always take a second to check that. Okay, if you have a negative slope, but your line's running uphill, that means you forgot to fall. All right. Now, this green part that I did right here, this was just a little bit of extra. You don't have to do that. You only need 2 points to graph a straight line. So you graph your B, your beginning point. You move from your M 1 time. Once you have that second point, you can draw a straight line. I would just use a ruler. Okay. All right. That is it. For your homework, I want you to do pages 137 and 138. You should be able to do them all. There's not too many problems. It's a lot of writing and a lot of space taken up with graphs. So it's really not a lot of work. Okay. And if you get stuck, especially on like one of the higher order of thinking ones or something like that, try it. If you get hung up, we will take the first 10 or 15 minutes of class tomorrow to address any questions you have. Now, what that does not mean is don't come into class with 2 problems done and say, I needed help on the rest. Nope. If you need that much help, I better be getting an email. Okay. If you come into class with 1 or 2 not done and say, I need help, then we're good. And we will have time in class to address those few questions. But please don't come into class with only the first 2 questions done and then try to tell me that you just didn't finish because you didn't have time or because you didn't understand it. You didn't finish because you didn't take time to do your homework. There is a difference. So please don't get an incomplete. Yes.
You say 137.
137 and 138. Okay, both pages. All right, for those of you at home, if you have any questions, shoot me an email. You can also watch the Savvis videos that are linked on Canvas as well.